Good morning. My topic today is development of microcrystalline HJT solar cell using 13.56 megahertz for mass production equipment. My name is Jinyan Zhang. In my presentation, there are 5 items. One is introduction to Goldstone. Goldstone has 200 patents licensed. Its main business, including development of solar cells technologies, development and sales of turnkey production lines of HJT cells, manufacturing and technology service support of HJT cells. The key owners: National Engineering Research Center of High Efficiency Solar Cell Equipment and Technology, national first major technical equipment in the field of new energy. And the company main competitiveness. There is 5 aspects. 1, advanced process R&D team led by PhD experts. And the second, core equipment development capability, and the core equipment such as PCVD made in Japan. And it also has mass manufacturing capabilities and experience. And GS has 4 units located in different areas in Quanzhou. One is Innovation Center, second, HJT R&D Center, and third, HPC R&D Center, and the 4th, equipment manufacturer base. Yes, major events. And GS started equipment and process development of thin film solar cells in 2005. And because time limit, I just want to make it shorter. And in 2020, the Chinese government confirmed its HJT equipment as national first major technical equipment in the field of new energy. And 2021, the efficiency of HJT cells fabricated in the production line achieved to 25.3%, and HPC solar cells efficiency to 26.14%. And same year, the National Engineering Research Center of High Efficiency Solar Cells Equipment and Technology is approved by Chinese government. And in 2022, it breaks world record of HJT modules efficiency for 5 times. So champion of HJT modules efficiency is 24.46%. And highest efficiency of HJT cells made in the mass production line achieved to 26%. And the GS HJT process development history. It started 2011. The lab's efficiency of the HJT cells was 20.5%. But to last year, 2022, the efficiency achieved to 25.4% as average, and the highest efficiency is 26%. Yes, experienced 7 generations of PCVD equipment. And from 2011, the first generation is only process 1 wafers in 1 chamber, 1 batch. But now, the 6th generation of PCVD can process 169 wafers in 1 batch. The 7th generation of PCVD, the chamber size will not change, but the capacity is 800 megawatts or 1 gigawatts for single PCVD equipment. HJT production turnkey solution and technical report. And for production turnkey solution, the major process including scattering of silicon wafers and texture and cleaning and PCVD process, PVD process, and silver grid and test. R&D progress of microcrystalline HJT solar cells. This slide shows 2 sketches of HJT solar cells. The left sketches is amorphous doped HJT cells, and the right sketches is N-doped and P-doped microcrystalline HJT solar cells. And here I need to mention that all the HJT solar cells was prepared by PCVD equipment using 13.56 microhertz RF technology. And the strength of 13.56 megahertz RF technology, there are 5 strengths. First, 13.56 megahertz of RF technology is perfect for large chambers of large chamber PCVD equipment using for mass production of microcrystalline HJT cells. And the uniformity of microcrystalline silicon films prepared by 13.56 microhertz is good. And process window of microcrystalline silicon film prepared by 13.56 megahertz is comparable, tolerant. Stability and reliability of HJT cell prepared by 13.56 microhertz is very good. We did not observe plasma damage on HJT cells performance caused by 13.56 megahertz glue discharge. Here is R&D progress of microcrystalline HJT solar cells. And from this chart, we can see that compared with normal HJT cells, that is N-type doped, P-type doped, amorphous silicon layers. And if we use N-type doped microcrystalline silicon and P-type doped amorphous silicon, the average efficiency of this structure increased by 0.5%. And if we use bifacial N-type doped and P-type doped HJT cell, and the average efficiency increased by 0.4%. And compared with normal HJT cells, bifacial microcrystalline HJT cells, the average efficiency increased by 0.9%. This is raw data of 3 structures of HJT cells. First is amorphous. Second is single microcrystalline line. Third is bifacial microcrystalline line. Let's see the RSC. And by using microcrystalline line and structure, RSC increased 100 milliampere. And VOC for single microcrystalline structure increased by 2.7 millivolt. And RSC decreased obviously. By using bifacial microcrystalline structure, VOC increased by 2.3 millivolt, and RSC continues decrease. And both fill factors and efficiency increased significantly. This is a QE result of different HJT cells. This chart we show three lines. One is a amorphous structure. Another is a single microcrystalline structure, and another is bifacial microcrystalline structure. Compared with normal HJT cells, EQE of microcrystalline HJT cells increase in both short and long wavelengths, obviously. This is the Raman result of microcrystalline silicon films. So left chart is Raman shift of N-type doped microcrystalline silicon or microcrystalline silicon oxide. And the left chart, right chart shows P-type doped microcrystalline silicon film and P-type doped microcrystalline silicon oxide film. And all this chart shows the one character. And there is a single crystalline peak at 520 appears in all these 3 charts, all 4 charts. And by simulation, this chart, we can calculate the crystallinity of all these 4 films. For N-type doped microcrystalline silicon oxide, the crystallinity is 48%. N-type doped microcrystalline silicon, the crystallinity is 54%. And P-type doped microcrystalline silicon oxide, the crystallinity is 44%. And P-type doped microcrystalline silicon, the crystallinity is 53%. The champion efficiency of HJT cells from a production line achieved to 26%. This result is certified by National Institute of Metrology, China. Here, I need to mention that the solar cells, the champion solar cells, we use a silver paste made in China, a single silver paste painting, and ITO, and the wafer size is 158 millimeter. R&D progress of microcrystalline HJT module. By using the high efficiency of bifacial microcrystalline HJT cells and optimized module lamination technique, we fabricated the HJT modules, and in last year we continues break the world record of HJT module efficiency 5 times. This is the result certified by TUV Nord. The chipping efficiency record of bifacial microcrystalline HJT module achieved to 24.46%. Also, this is also world record of monocrystalline solar modules. Result from our customer. This is the efficiency ramping up change of the mass production line from the mass production line. The result shows us that average efficiency of bifacial microcrystalline HJT cells fabricated by our government achieved to 25.2%. Compared with normal HJT structure, the average efficiency of microcrystalline line HJT cells increased by 0.8%. HJT efficiency increase roadmap. This roadmap is for production line, and our target is in 2026, the average efficiency of HJT solar cells fabricated in turnkey mass production line will be 26.2%. Here I list 5 potential techniques. One is bifacial microcrystalline layer optimization. Second, silicon interface preservation optimization. Third, new TCO. Fourth, new types of silver paste. Fifth, new metal grid pattern technique. Sixth, hyperfine copper plating technique. Seventh, high quality and large size of silicon wafer. Conclusions: 13.56 MHz technique is perfect for large chamber PCVD equipment used for mass production of microcrystalline HJT cells. Efficiency of microcrystalline HJT is 0.9 higher than normal HJT cell. Champing efficiency of microcrystalline HJT cells from mass production line achieved to 26%. Champing efficiency of bifacial microcrystalline HJT module is 24.46%. Is breaking the world efficient record of monocrystalline modules. The average efficiency of bifacial microcrystalline HJT cells made by our customers achieved to 25.2%. That's all for my presentation. Thank you very much.